this video is designed to complete what has been mentioned in the workshops in College of Medicine and Nahrain University regarding preoperative planning for total hip replacements. In this video we will try our best to explain what is templating. Templating is one part of planning, it is not the whole part of planning for total hip replacement. So this short video I hope that inshallah I will explain or try my best to explain the template, radiographical templating. Usually radiographic templating passes through 4 stages or 4 steps. This has been already mentioned in the PowerPoint lecture. The first step is to verify whether the radiograph is adequate or not. If the radiograph is not adequately exposed or abnormal, unusual magnifications, this will make error in the subsequent steps, and the overall templating will be not valid. So the first step is to verify whether this X-ray is adequate for templating or not. The requested X-ray, it is NIP. This radiograph should be centered, or the exposure should be centered around the symphysis pubis. And checking whether this radiograph is adequate or not involves 3 main points. The first point, regarding the pelvic side, we should verify whether the pelvis is adequately exposed or not. The second, regarding the femurs, and the third one is for magnification. So to start with, I will check that the pelvic X-ray is adequate. This can be verified by the following items. First one is that both obturator foramen both should be symmetrical, this one and that one. If these 2 foramens are not symmetrical, this means that the pelvic had oblique or other than the true AP pelvis. This is the first point. The second point, that the tip of the coccyx should lie above the superior edge of the symphysis pubis. This is the second point. And the third one, that when I pass a vertical line through the symphysis pubis perpendicular to the interteardrop, this is the teardrop, U-shaped teardrop, this is the other one. If I draw a line via the symphysis pubis perpendicular to the interteardrop line, it should bisect the sacrum symmetrically. This line should pass through the middle of the sacrum. So always all of us should memorize these points regarding the adequate AP pelvis. The coccyx is above the symphysis pubis. The obturator foramen, both right and left, should be symmetrical, and the line through the symphysis pubis should bisect the sacrum. This is from the pelvic side. Regarding the femoral side, how I will check that this is adequate AP or not? The lesser retrocanther should be partially uncovered. As we know that like posteromedial. So in true AP, majority or the medial cortex. Only part of the lesser retrocanther is visualized. It has been said that this visualized part should be around 2.3 mm to 3.1 mm maximally visualized. If more than 3.1 mm is visualized from the lesser retrocanther, this means that the whole femur is rotated externally, so that more part of the lesser retrocanther is visualized. So this is one point. Another point is that the greater retrocanther should be maximally visualized. As we know also, if we abolish the anteversion of the neck of the femur, internally rotate the femur around 15 degrees, the greater retrocanther would be maximally visualized. And check that the femur is adequate regarding rotation. It should be internally rotated 15 to 20 degrees to abolish the anteversion. If we are in the right side, in the right scale of internal rotation, the lesser trochanter should be minimally visualized and the greater trochanter is maximally visualized. This is the second point regarding we are taking a good NIP view. The third point is magnification. The template of the femur, the template for prostheses are designed for certain degree of magnifications. This certain degree of magnification should be compliant with the magnification of the radiograph. How can I check magnification of the radiograph? Usually we put a metal ball while we are taking the X-ray, we should put a metal wall of non-dimension. For example, it is in reality it is 10 millimeter, and we tie the two thighs of the patient at the level of the lesser, not directly on the cassette, not on the skin of the patient. It should be at the level of the lesser trochanter. So we put this metal ball, for example, it was a 10 millimeter, and we took a radiograph and measure this ball in the radiograph, and we can calculate the magnification. Of course, this magnification is much easier to be calculated by digital planning. By the way, digital planning does not substitute the manual templating. Of course, in the majority of centers all over the world, they adopt the digital planning, digital software, digital radiograph, and digital programs or software from the manufacturers. It is much easier, time consuming, it is much less time consuming than the manual, but it does not substitute the necessity or the need for manual templating. Because digital planning or digital templating, let us say, is not completely automatized. It is operator dependent. How the operator can manipulate the software, he should know these principles that are mentioned in this video. So, in summary, first, step 1 for planning is adequate X-ray. X-ray means adequate pelvic side, adequate femur side, adequate or well-known magnification. We have finished the first step of templating. The second step would be to draw bony landmarks on the pelvis, and as well as bony landmarks on the femur. So the second step is to draw bony landmarks, relevant bony landmarks. The most consistent landmark is the teardrop. On the pelvic side is the teardrop. This is the teardrop. We should draw it like this, U-shaped. In addition to that, the other side. Because interteardrop line, this is the second landmark, interteardrop line is a reference line, or what we call a leveling reference line. If the pelvis is already tilted like this or that, we can compensate for this tilting by the interteardrop line. If the teardrop is not visualized, for example, dysplastic hip, post-traumatic hip, we can depend on other leveling lines like the line in between the ischial-tuberosities or the line between the inferior edge of the sacroiliac and sacroiliac, and we can draw a line and we regard it as a leveling line. This leveling line is very important to measure the hip length, the limb length, and other indices that we will see in this video. In this case, the teardrop are visualized, so the most dependent is the. So the second step is the templating is to draw a bone landmarks. Bone landmarks from the pelvic side, we have teardrops, interteardrop line. We should draw the obturator foramen. This is the third bony landmarks that should be fixed in the pelvic side. And the fourth one is the pelvic or acetabular floor. These lines, 1, 2, 3, and 4. This is the pelvic side. What about femoral side? Femoral side also 4 bony landmarks should be fixed. This is the lesser. This is the greater. And the saddle area. The saddle area is important because it is easily palpated perioperatively, so that we can make it a reference lines or reference point. So first one is lesser, second is the greater, third is the saddle, and the fourth is the intramedullary line of the femur. How we can draw the intramedullary line? We use the diaphysis, taking midpoint in the far away from the lesser trochanter, another point in the middle of the medullary canal, and we draw a line. This line is intramedullary line. This is very important because the offset will be measured from it, and the overall alignment of the stem would be guided by this line. Of course, we should draw the same bony landmarks to the other side, the greater, lesser, saddle area, and the intramedullary line of the femur. By doing this, we have finished the second step of templating, which is drawing a bony landmarks. The third step is to define the mechanical axis, the center of rotation, sorry. Center of rotation is very important to be decided from the normal and transfer this normal to the abnormal. Of course, in this abnormal hip, I cannot decide where is the center of rotation. So what I will depend is that I go to the normal hip, define the center of rotation, and transfer the same data to the abnormal hip. How can I define the center of rotation in the normal hip? Two ways. Either depending on the intact head, this circular templates for defining the center of rotation of the head. Because this hip is normal, so the center of rotation of the head of the femur is the same to the center of rotation of the acetabulum. This is in normal hips. So either we define the center of rotation of the head by doing these templates. For example, this is 44 is not adequate. This is 46 is adequate. I can define the center of rotation by superimposing this point into the X-ray. This is the center of rotation for the head of the hip. It is the center of the acetabulum. I can further double check that I superimpose this templates for the acetabulum, different sizes. My guide is the normal acetabular floor. For example, this is 51 is not adequate. I will depend on 54. This acetabular floor coincides well with the template of the acetabulum. And the inferior edge of the acetabulum does not go down the interteardrop line. And what is very important is that this point will be highlighted in the other side. The line drawn from the lateral lip of the teardrop, this is the teardrop, a line drawn from the lateral lip of the teardrop perpendicular to the interteardrop line, the acetabulum shouldn't pass medial to this line. Otherwise, there is a risk of what we call perforation of the middle floor and risk of protrusion. So by doing this, also I can define the center of rotation. This is the same. So this is the center of rotation of normal hip. How can I transfer these parameters to the other side? I draw a line perpendicular to the interteardrop line. This is the interteardrop line. I draw a line perpendicular from the center of rotation to this interteardrop line. This is the center of rotation. I draw a line perpendicular to the interteardrop. I ended with this imaginary triangle. So I measure the distance of this one and that one, the intersection of this line to the tip of the teardrop. And I transfer these data into the other side. For example, in this case, the horizontal line is about 3 centimeters and 2 millimeters. So from the tip of the lesser trochanter, I calculate 32 millimeters, which is like something like here. And I measure the vertical line, which is about 20 millimeters. Also perpendicularly from 20 millimeters from this side. So the center of rotation for the abnormal side will be like something like here. This point is very important because when I am doing the replacement and after finishing my job, the center of rotation of the hip should be in this point to have symmetrical centers of rotations for both sides. We have finished the third step of templating. Just to memorize you, the first step is to adequately verify that it is adequate AP regarding pelvis, femur, and magnification. The second step is to draw 4 landmarks from the pelvic side and 4 landmarks from the femoral, and to check the magnification. The third step is to define the center of rotation to the normal side and transfer to the abnormal side. What about in some cases we do not have a normal side, we have both hips are abnormal? The idea here is that to have a symmetrical center of rotations for right and left, we cannot 100% sure that this center of rotation was the same normal center of rotation, for example, 10 years ago. So in this case, if we have a bilateral hips, abnormal hips, we can imagine the less center of rotation. By which method? Usually, the hip when distracted, usually some remnant of the acetabulum remain here in the infero-medial part. So we can't depend on this infero-medial part to make templating or to make the cup size. The cup orientation and side, which will define the center of rotation. This is usually a theoretical point to still have some remnant of the acetabulum remaining in the infero-medial. Usually in reality we have a completely distracted hip, the acetabulum. In this case we can imagine some center of rotation by doing the templates, putting the templates of the acetabulum just the same as I mentioned previously. The inferior lip of the acetabulum shouldn't pass inferior to the interpterygoid line and shouldn't pass medial to the lateral lip of the pterygoid. For example, I put this template with these criteria. Do not go below the interpterygoid, do not go medial to the lateral lip, and slide and cover. I will put the acetabulum, for example, in normal inclination of the hips normally is around 50 to 55 degrees. I am talking about normal acetabuli. Usually the angle of inclination in normal acetabulum is 50 to 55, so that we can incline the template around 50 to 55 and see the overall template on this hip and define the center of rotation and transfer this center of rotation to the other side, just to have centers of rotation in both right and left. In this case, in this radiograph, we have normal hip. Easier is to define the center of rotation with much certainty and transfer the center of rotation to the abnormal side. Now we have reached to the fourth step, which is the final step of templating. That's to say, setting the implants. Setting the implants is that both acetabular as well as the femoral side. Before I am going to the fourth step, I think that we should explain what is the criteria of the templates. Example of one company is a template for the femur as well as for the acetabulum. This is of course this template for the lateral view, because templating is AP and lateral, is routine. We are explaining in this video only AP, and this is the template for AP. I think I should explain in more details what are the criteria for this template. This template contains the name of the company, of course, because templating is different from the templates, is different from the one company to other according to the manufacturer criteria. The second one, it should contain whether it is cemented or cementless, because it is much different regarding the shape as well as the dimensions. And here is the scale. And for this case, for example, the scale is 1:15 to 1. That's to say, 1 centimeter in reality appear in this template as 11.5 millimeter. So the magnification is 15%. That's to say, we should use this template only in appropriately magnified radiograph of this figure. Of course, in digital templating is it much easier, because in the software we have the magnifications of the radiograph, and we can set the magnification of the templates accordingly. The third criteria is that this stem contains this longitudinal line. This longitudinal line should coincide with the medullary line of the femur. Because if it does not coincide with the medullary line of the canal, this means that we have already put the stem in varus or valgus. This is another point should be maintained in our mind. The second one, the other point is that the level of the osteotomy. This oblique line indicates the level of osteotomy, the proper level of osteotomy. And as we see that there is a small ruler here, measuring the distance from the lesser trochanter, suppose the lesser trochanter would be here, somewhat here, we can measure in this template the distance of the osteotomy from the lesser trochanter. For example, 1 centimeter or 2 centimeters. If the lesser trochanter is not visualized, we can use this ruler. What is this small ruler? It measures the distance of the osteotomy from the tip of the greater. All of us imagine the greater trochanter around here, so that we can say that the level of osteotomy is around 2.5 centimeter from the level of the tip of the trochanter. Another issue very important is these landmarks. As we know that the usual standard offset of the femur is 132 usually. Majority of the manufacturers manufacture the stem of the femur neck shaft angle. There is a strong need for H offset, what we call the H. H means high. That's to say that the neck shaft angle is not 132, it is less than 130, usually 127. So in this template we have two necks, two neck S. This neck is for the standard and the other one is for the offset. And of course we have a head for this solid line for the standard S offset, and the dotted lines indicate the level of the head for the H offset. This is another issue. The last issue is that if I think this is clear in the video, what called SML. This what does this indicate? This indicates the neck length. For example, small, if we go to the medial, this means increase the neck length. By increasing the neck length, we will increase both medial offset as well as the vertical offset. These dotted or these apertures or small opening, this indicates the center of rotation for the hip, for the stem. For example, in my template, I will strongly depend on this small circles. When I put my pencil here, I mean that this center of rotation would be in the future for the stem. I will try to explain it more in details while I am doing the tracing. By finishing this, I think I should highlight another point. For example, on this hip, I have a neutral or relatively slightly adducted femur and more adducted femur. I cannot measure the limb length while still the femur is adducted, because this will cause an apparent shortening as well as to the real shortening. There is a real shortening due to distracted hip, but also there is an apparent shortening due to adduction. In adduction, the lesser trochanter would go above, would go higher, and this will cause apparent shortening, in addition to the real shortening. So I have to put, when I am comparing the offsets, the hip lengths, all the comparable criteria for the right and left, both femurs should be in the same position regarding abduction and adduction. How can I make this? Usually by software, by digital planning, it is easier just to map this line and give an instruction to the software to abolish the abduction. But what I'm doing here is the manual templating. I cannot do manual templating while the hip in adduction, it should be neutral. How can I neutralize the hip? By what is called the tracing. The tracing is that this transparent paper, I will draw the pelvic side at one moment, and another moment I will draw the femur, the normal femur, and another and last moment I will draw the abnormal femur. I will show you in details how can I abolish this adduction and do the final template. And templating is the fitting the implants. To start with, I should fit the implant of the acetabulum, the acetabular component of the total hip. How can I fit this implant for proper fitting? There should be certain criteria that when I fit the acetabulum, how can I verify that it's perfect? Just a rapid through the template of the acetabulum. It contains just a half circles with different diameters and the center of this circle. The first step is to fit this center in the template with the center of rotation. This is the first step. I should fix the center of rotation in the template to the center of rotation in the radiograph. The second step is to incline the acetabulum around 45 degrees to the interteardrop line. This is the interteardrop line, and this is the cup inclination. This angle should be around 45. This is the next step. The third step is that I should verify that the inferior edge of the acetabulum does not go below the interteardrop line. And another issue that just I have mentioned shortly, that the line drawn through the lateral lip of the teardrop, a line drawn through the lateral lip of the teardrop perpendicular to the interteardrop line. Just imagine this ruler is a line drawn perpendicular to the interteardrop line, just with the lateral lip of the teardrop. The medial part of the acetabulum shouldn't pass medial to this line, because this will mean the protrusion. Of course, when I put this size, for example, this is size 50, I still have some part of the acetabulum is not rimmed well, and still I have some space to rim. So I will go to the upsizing. 50, I will go to 52, just the same, coincide the center with the center. The angle would be 45 degrees, and see what is going on. Still, we have some spaces here. We can go to the upsizing, which is 54. The 54 also, I adopt the center of rotation of the template with the center of rotation of the radiograph, incline the acetabulum 45 degrees. In this case, I think it is perfect, because the inferior acetabulum does not go below the interteardrop line, and the medial acetabulum just with this line, which is perpendicular to the interteardrop from the lateral lip of the teardrop. Of course, when I template this angle of inclination of 45, I should have some uncoverage here superiorly, because as I said that normally the acetabulum is inclined about 50 to 55, while in templating and in replacement usually we incline the acetabulum 40, so usually we make it more horizontal than usual. This means that there should be some uncoverage here. If this coverage is less than 10% of the surface of the acetabulum, this is acceptable. If it is not, for example, uncoverage around 20%, this is not acceptable. What other options I can have to compensate for this uncoverage? There are a lot of points. Some points I should keep the superior osteophytes. If I have some osteophytes superiorly, I should keep it. Do not try to remove it, because this will aid in coverage superiorly. Or we can also incline the acetabulum in more vertical. For example, not 45, I can still safely go to 50. So in summary, the acetabular templating of the acetabular component, we coincide the center of rotation of the template with the center of rotation in the radiograph. This is the first step. The second is to incline it, the acetabular cap is 45, around 45 degrees with the interteardrop line. The inferior below the interteardrop line, and the most medial part of the acetabular component shouldn't go medial to the line drawn from the lateral lip of the teardrop perpendicular to the interteardrop line. By doing this, usually we end with a slight uncoverage superiorly. Why this uncoverage? This is usual one, because the normal acetabulum inclination angle is 50 to 55. We incline the component in 45 degrees. That's to say, in more horizontal inclination compared to the normal side, to the normal acetabulum. So there should be some uncoverage. How to deal with this uncoverage? If this uncoverage is less than 10% of the surface area of the whole cap, this is acceptable. But if it is more, for example, 20% of the acetabular outer surface area is uncovered, what to do? One option is to keep the osteophyte, the superior osteophyte. Usually in some cases of osteoarthritis, we have some large osteophyte superiorly. While we're doing the arthrotomy, we should keep this osteophyte superiorly, which will aid in this coverage. This is one solution. Another solution is to incline the acetabulum, the acetabular cap in more vertical way. That's to say, for example, not 45, we can do the inclination about 50. By doing this manipulation from 45 to 50, the uncoverage would be less than that with the 45 degrees. Of course, another option is if this still the uncovered is unacceptable, we can deal with bone graft and a lot of other solutions. So by finishing this step, we have already determined the size of the acetabulum. It is in this case, for example, it is 56 millimeter cup size. The angle of nucleation is 45 degrees. The next step is to bring this tracing paper. This transparent tracing paper, as I said, is mandatory to compensate for the femur adduction. I superimpose this tracing paper on the radiograph as well as the template. I keep the template of the acetabulum in situ. So 3 layers. Layer is radiograph, the second layer is the transparent template, and the third one is the transparent tracing paper. What I will do in this step, I will draw what is shown in the pelvis, all the pelvis, the normal and the abnormal side, together with the acetabular cup. I will mark it on this tracing paper. So I will start tracing this hemipelvis, normal hemipelvis. Still I am in the normal side. Only the pelvis. We shouldn't draw in this step the femur. This is the teardrop, and this is the center of rotation. These very important 2 landmarks should be fixed in the pelvis. Going to the abnormal side, also I will draw the right hemipelvis. Also, the teardrop should be fixed, as well as the center of rotation. Later, I will draw the templated acetabular component in the green, by the green color pen. This green colored marking is the acetabular component, and the black marking is the whole pelvis, right and left, together with the teardrops and the center of rotation. So I finished the templating the pelvis. Now, in this step, I had finished with tracing paper, fixed both hemipelvis, the whole pelvis, together with the teardrops, both center of rotation as well as the acetabular component templating. What is the next step? Is to template or to draw the both femurs, starting with the normal femur. Of course, if you observe it clearly in the video, the normal side femur is also slightly adducted. If I kept this adduction, slight adduction, it also gives an error in the hip length or limb length compared to the other side. So I have to neutralize both femurs, the right and left. How can I neutralize it in the tracing paper? By this way. This is the center of rotation. This is the center of rotation. It is a fixed point. I adapt or coincide the center of rotation in the tracing paper with the center of rotation in the radiograph. And I fix the relation of the tracing paper with the radiograph by this method, by this maneuver. So the tip of this pencil to the center of rotation. I will try to rotate the whole tracing paper in this way and that way, so that the edge of this paper would be parallel to the intramedullary line of the femur. So this is the edge of the paper, of the tracing paper, and this line is the intramedullary of the femur. I shouldn't keep this tracing paper like that. The edge is not parallel to the medullary line. I rotate the paper till it's parallel. So this line is parallel to that line. By doing this, I will draw the whole femur. Fix this paper, and I will try to draw the whole femur. Still I am in the normal side. I will draw the whole femur, lesser trochanter, the neck, the saddle area, of course, as well, because this will guide my measurement for the offset. What I have done is that slightly adducted femur in this radiograph, make it neutral in this way by doing this maneuver. Going to the abnormal side, to the right hip, what shall I do? I will start now templating the femur. I will take this template for the femur, for the AP, and I will align this longitudinal line in the template as I have described it just shortly, that this line should coincide with the longitudinal axis of the femur. That's to say, with this line. So I coincide this line and with the stem together with the line of intramedullary. And I will start to shift the whole stem inferiorly, just as if I am doing broaching of the femur during operation. How much I will go below or up, this will depend on the following criteria. In the cementless stem, I am not too flexible. I should depend on the bone geometry. So my descent or ascent in the stem within the femur depend on the geometry of the bone compared with the stem. I shouldn't go much below, because in this case I should remove this part of the neck, which is not acceptable. If I go too much above, this will leave too much neck, and this is also not acceptable. So I slightly try to descend to shift the whole stem, still in the longitudinal axis of the stem with the longitudinal axis of the until I got good fitness or optimal fitness of the stem. Optimal fitness means what? 1 millimeter around the stem, still cancellous bone. I shouldn't trim the whole cancellous bone here, because stem to cortex contact is not allowed. I should keep some cancellous bone around the stem in both cemented as well as cementless. So around 1 millimeter of cancellous bone is still visualized all over the stem, and in the metaphysis maybe 2 millimeter. This is maximum acceptable cancellous bone to be left around the stem. The second one is that this curve on curve, this calcar, this is the curve of the stem. It should fit curve on curve, so that during reaming I will not face the problem of broaching the calcar. By doing this, I am satisfied that this stem is optimal. If not, I can choose another templates with another size. For example, this is size 12. I have from this manufacturer from size 15 or even more. So I start downsizing the stem or upsizing accordingly. For example, of this, I am satisfied that it is 12, it is cementless, and I will fix this transparent templates to the radiograph and bring my tracing paper. What I will do in this tracing paper, I will try to compensate also, as I mentioned, for adduction of the hip, of the femur. How can I compensate? By this tracing paper. Another points I should highlight it also, I repeated, that these circular small circles coincides with the center of rotation in the stem. These three, small, medium and large. This denotes for what? For the center of rotation regarding the small size neck, medium or large and even more. So my future center of rotation for the femur would be either this point or that one according to which type of neck I chose. So also my tracing paper, I keep this relation of this template with the radiograph, and I bring my tracing paper. This is the center of rotation. My future. I will coincide this center of rotation with one of these neck lengths. For example, I will choose in this example the medium one. So I will coincide the center of rotation in the tracing paper with the medium, and also I put my pencil so that the center of rotation would be fixed. Also, I will try to rotate the whole tracing paper so that the rim or the edge of the tracing paper is parallel to what? Is parallel to the longitudinal line
of the medullary. For example, in this case, this is the line, the intramedullary line of the femur, which is the same as the longitudinal line of the stem. This is the line. And I should rotate my tracing paper so that the rim of the paper is parallel to that line. Keeping in mind, I should keep the center of rotation with the sternum with that of the stem. Just repeat the same procedure. This is not acceptable because this is not acceptable because the longitudinal line of the medullary is not parallel to the paper. So I will try my best to parallelize the rim of the tracing paper with that of the template or the medullary line. I think this is more perfect. By doing this, I will trace or put my landmarks in the tracing paper, all the things regarding the radiograph as well as the template regarding this site. So I will draw by this red line the femur. The femur with all the landmarks that I have fixed in the first step. That's to say the greater retrocanta, the lesser retrocanta, the saddle area, as well as to the medullary line of the femur. And also I will draw the stem, the templated stem. In this example, I templated with this violet color pen. I will choose here the standard one, that's to say the neck shaft angle of 132. And draw the whole stem in the template. Of course, with the whole stem, I should draw the level of osteotomy, which is already fixed in the template. This is the drawing of the stem. By finishing this, I can remove all the things apart from the tracing paper. This is tracing paper. I have finished with whole pelvis, both right and left femurs with a neutral position. Not the right, not the left is adducted. Just compare this one with that one. That was adducted. This one is adducted hip. While we transfer, this is also the same picture, templating. This was adducted hip. This tracing paper, it is neutral, both femurs. By doing this, I can fix my results. What are the results to be judged from this templating is the following. To start with, I have to cup size. The cup size, for example, in this case was 54 millimeter. The angle of inclination was 45. Stem size was 12. Stem type was cementless. Stem offset was the standard, not the edge offset. What left also is the level of osteotomy. I can measure the level of osteotomy directly on this tracing paper as the distance from this level of osteotomy to the either the proximal end of the lesser trochanter or the tip of the lesser trochanter. I can measure this distance directly by this ruler. It was about 2.5 centimeter. So that perioperatively I will do my osteotomy, neck osteotomy, 2.5 centimeter from the tip of the lesser trochanter. What else? This is so level of osteotomy is 2.5 centimeter from the lesser trochanter. What about our main two targets? That's to say, limb length discrepancy assessment as well as the offsets. How can I measure that? While I'm doing this templating, I will end with adequate limb length. This could be measured by the following way on this tracing paper. Drawing a line, as we know that the hip length is the distance from a pelvic point to a femoral point. So I will choose from here, it is from the tip of the both lesser trochanter, this is one line. This line assesses the distance of the lesser trochanter from the pelvis. From the pelvis, I can choose the interteardrop line. I will measure the distance, the perpendicular distance from this teardrop, perpendicular line to the interlesser trochanter line. I will draw this perpendicular line. Which in reality usually parallel to the intramedullary line of the femur. Also doing the same for the abnormal hips. Draw a perpendicular line from the teardrop to the interlesser trochanter line, and we can measure these two figures. If there is an unacceptable limb length discrepancy, I should manipulate my whole templating. If it is within the same acceptable limits, that's to say shortening of half cm is acceptable. If it is more, I have to compensate for this lengthening. For example, in this template, I will end with unacceptable lengthening of the replaced part. For example, to be more accurate, I will measure this to be around 4 cm, while in this it is 5 cm. So 1 centimeter lengthening may be not acceptable. What I will do, I can modulate my templating by choosing, for example, not a medium. In this case, I chose the medium neck length. I will choose the small one. By doing this, the small neck length, I will shorten the replaced part so that to compensate for this unacceptable lengthening. This is one solution. Another solution is to modify my level of osteotomy, etc. So this is the way how I will measure the limb length discrepancy, or more accurately, it is a hip length rather than a limb length. The second or final step is the offset. How can I measure the offset? Going to the normal side, I will draw a line from the center of rotation perpendicular to the medullary line. This is the definition of the offset. Also for the replaced part, from the center of rotation perpendicular to the medullary line. This is the left offset. I measure it by ruler. In this case, it is around 4 cm, femoral offset. While in the replaced part, it is 5 or maybe 4.7 centimeter. So there is an increase in the medial offset, which is not acceptable. The ideal one is to have symmetrical femoral offset here and there. This is the normal one, 4 cm. I should have the same offset, femoral offset to the replaced part. How I will decrease this offset? Many solutions for that. For example, in this cementless stem and in this sample where I have got lengthening of the limb as well as increasing the offset. How I can decrease this offset and decrease the limb length? By choosing a smaller neck. That's to say too small, because when I am decreasing the neck length, it will shorten both the hip length as well as the offset. By interpreting this this templating, we may face with some problems. For example, if I am comparing the offset of the normal side with that of the replaced part, if the replaced part had less offset than that of the normal, I should increase the offset. By which method? By choosing the edge offset. That's to say, I choose the template of the edge offset, which is the high offset. The high offset will increase the medial offset of the femur without affecting the hip length. This can solve the problem if I have less offset
in the replaced part compared to that of the normal. But what to do if I have increased offset compared to that normal? I should decrease it. By which method I can decrease the medial offset, not increase? I can decrease this medial offset by a lot of ways. If I am dealing with a cemented type of stem, I can put the stem slightly in valgus. This will affect the offset. This will decrease the offset. But what to do if I am dealing with a cementless stem? In the cemented system, I cannot play regarding the position of the stem. In this way, I can solve the problem of increasing the offset by choosing less neck length. For example, if from the start I chose the medium, I will choose the small neck length. By choosing a smaller neck, I will decrease and I will solve the problem of the medial offset increment. But choosing smaller length will also affect the hip length. If I am still within the safe acceptable limit of limb length discrepancy, I will go forward. But what to do if I face an unacceptable shortening? In this way, I can change my level of osteotomy so that the whole stem will go upward, compensating for the hip length shortening. So in summary, after finishing the templates, I should fix all these findings: the cup size, the inclination, the stem size, it is size 12 in this example, the stem type, it is cementless, stem offset is standard, level of osteotomy is 2.5 centimeter from the middle of the lesser trochanter, the limb length discrepancy compensated, it is around, for example, I accept a half centimeter shortening acceptable, and the offset is symmetrical, right equal to the left. And lastly, I should fix the neck length. For example, in this, medium is not acceptable, I will solve with the small. I should put all these figures in front of my eyes in the operative theater. For example, because all these figures should be memorized during operation, and during operation I will go to revise these figures per-operatively. By doing this, we have finished the templating of the for the total hip replacement. A little bit complicated by doing tracing. Also, I will emphasize the same point. I was obliged to do this templating, this tracing paper, because I have already an adducted hip. If I don't have, from the start, I do not have adducted hip and can put both in a neutral position, there is no great importance of doing this tracing paper. I can template by using this radiograph as well as to the radiolucent template without doing tracing. If I have a neutral femur. If I cannot have a neutral both femurs regarding hip adduction and abduction in the X-ray, I should do this maneuver of tracing and doing all my measurements on this tracing papers rather than the original radiograph. Thank you very much for listening to this video. Thank you very much.